Load the GIS App 3 project from the last tutorial. Open the database editor if it isn't already open. We'll use imported shapefile vectors to bound ecosystems and corresponding attributes to determine ecosystem type and foliage density. Open the landcover100k.met text file from the DVD data folder. The Spatial Reference Information section describes the data in the same geographic NAD 83 coordinate system we've been using. Go to the Entity and Attribute Information section and find the Detailed Description subsection. There are 4 attributes we're interested in: primary, prime percent, secondary, and sec percent. Primary defines the land cover type that covers most of the polygon. The lcname.txt file lists codes and corresponding land covers converted from the lcname.dbf file described in the metadata. Prime percent is the percent coverage of the primary land cover type in the polygon. Secondary defines the land cover type of the remaining polygon area. Sec percent is the percent coverage of the secondary cover type. Launch the Import Wizard. Go to the Data folder on the DVD and open landcover.shp. The wizard will correctly identify it as a shapefile. Go to the next window. The Load As window doesn't offer any options, so continue to the next window. We'll have VNS name the vector objects, this time land cover. Go to the next window. As expected, the Coordinate System Editor pops up for guidance. This shapefile continues our tradition in the geographic NAD 83 system, so select it from the System drop-down list. Close the editor. The Coordinate System Summary will update with the new system information. Continue to the next window. The Shape Options window opens to the Attributes section. I've modified the original Wyoming Natural Resources shapefile. Vectors outside the terrain and unneeded attributes have been removed. Deselect Assign DB names from an attribute field and select Conform to Terrain. Ecosystem vectors don't need to be conformed to terrain, but it will make them visible in perspective camera views. Import the data. The first Database Fields window is looking for attributes. Multiple select primary, prim percent, secondary, and sec percent. Note that the shapefile only contains the first 10 characters of the attribute label described in the metadata. The second Database Fields window is for assigning database layers. Multiple select primary and secondary. Import the data. The loading window will disappear when data import is complete. The real-time views will refresh with the land cover vectors in red. Save the project as GIS App 4. Select the land cover 1 vector in the database editor to refresh the total objects count. Go to the Attributes page and you'll see the 4 attributes we loaded. The Layer page lists the primary and secondary layers. Search the object list. Remove the number from the land cover prefix in the Input Request search string field and search the database. The land cover shapefile added 26 objects to the database. Add a layer. Name the layer Land Cover. Save the project. Up to now, the use of search queries and thematic maps has been fairly straightforward. Ecosystems are usually more complex, which is why we left them until last. There are a couple of options for setting up our ecosystems. We could create an ecosystem for each primary and secondary land cover combination, which would give us the greatest control over each ecosystem. It would also be a complex and time-consuming approach for a large project. We could use one ecosystem and control primary and secondary coverage from Ecotype Foliage Groups. While an elegant solution, this would remove our ability to use unique distance-dissolve textures for each ecosystem. We'll compromise and do something in between. We'll create ecosystems based on primary land cover and use thematic maps within the Understory ecotype to control secondary coverage. Primary and secondary land cover will be represented by Overstory and Understory ecotypes, respectively. First, we need to determine what primary land cover groups we have. Search queries will be a big help here. Go to the Vector Task Mode and expand the Search Queries category. Add a generic search query. Go to the Database Editor. Select the Land Cover 1 object and open its attributes page. The primary land cover code is 42016. Name the search query P42016. Go to the Selected Filter page. Search the primary attribute field for a value that equals 42016. Return to the General page and select Items Now. The Database Editor will show 15 of the land cover objects selected. Disable the objects so we know where we've been. Select the Land Cover 2 object. The primary land cover code is 62002. Clone the P42016 search query in the Scene at a Glance. Name it P62002. Go to the Selected Filter page. Change the primary attribute field value to 62002. Return to the General page and select Items Now. The Database Editor will show 2 of the land cover objects selected. Disable the objects. Select the Land Cover 3 object. Its primary land cover code is 42004. Clone one of the P search queries and rename it P42004. Go to the Selected Filter page. Believe it or not, we're going to change the primary attribute field value to 42004. Return to the General page and select Items Now. The Database Editor will show 6 of the land cover objects selected. Disable the objects. Select the Land Cover 8 object. Its primary land cover code is 82002. Clone a P search query and rename it P82002. Go to the Selected Filter page. Change the primary attribute field value to 82002. Go back to the General page and select Items Now. The Database Editor will show 2 more of the land cover objects selected. Disable the objects. Not to worry, we're almost done, so select the Land Cover 11 object. Its primary land cover code is 74001. Clone a P search query. Rename it P74001. Go to the Selected Filter page. Change the primary attribute field value to 74001. Go back to the General page and select Items Now. The database editor will show one land cover object selected. That's the last one. Turn to the Layer page. Select the land cover layer and enable the objects. Save the project. It may have seemed like longer, but it took only 5 search queries to find all the primary land covers. We'll create one ecosystem for each primary code, which means 5 ecosystems. Let's name the ecosystems according to search query, starting with the first one. Go to the Land Cover task mode, expand the Ecosystems category, and add a generic ecosystem. Name it P42004. This ecosystem should render within all vectors whose primary attribute is 42004. Go down to the Dynamic Link drop-down list and select the P42004 search query. Go to the Material and Foliage page and open the Diffuse Color Editor. Change the color to 255 red, 0 green, and 0 blue. Save the project. Clone the P42004 ecosystem 4 times. Rename the open clone P42016 and select the P42016 search query from the Dynamic Link drop-down list. Turn to the Material and Foliage page and open the Diffuse Color Editor. Change the color to 0 red, 255 green, and 0 blue. Edit previous object of same type, turn to the General page, and rename the ecosystem P62002. Select the P62002 search query from the Dynamic Link drop-down list. Flip to the Material and Foliage page and open the Diffuse Color Editor. Change the color to 0 red, 0 green, and 255 blue. Edit previous object of same type again. Go to the General page and rename this one P74001. Select the P74001 search query from the Dynamic Link drop-down list. Go to the Material and Foliage page and open the Diffuse Color Editor. Change this color to 255 red, 255 green, and 0 blue. Edit previous object of same type, turn to the General page, and rename this ecosystem P82002. Select the P82002 search query from the Dynamic Link drop-down list. Go to the Material and Foliage page and open the Diffuse Color Editor. Change the color to 0 red, 255 green, and 255 blue. We'll render a plan default preview, but we don't need the 10-meter DEM resolution. Search for YNP-100. Enable the 100-meter resolution DEM. Select the FRZ YNP-10M DEM above it. Activate the Frozen DEMs layer and disable the layer. That will speed up renders while we're testing ecosystem search queries. Save the project and render a plan default preview. 5 different colors represent the 5 ecosystems we just created. Ecosystem boundaries appear as red vectors. Let's see how we're doing with effects memory use. Open the status log. Ecosystem memory requires about 60 megabytes at a resolution of 10 meters. Enable the Frozen DEM layer and disable the YNP-100M DEM. Save the project. Open the Madison River camera in the upper left view and render a preview. The P42016 ecosystem includes 15 of the 26 land cover vectors, so let's build it first. According to the lcname.txt list, 42016 is burned conifer. That's the primary land cover, so we'll make it the Overstory ecotype. Open the P42016 Ecosystem Editor. Go to the Material and Foliage page and create an Overstory ecotype. On the Ecotype Editor General page, make the absolute height in the Foliage group and absolute density in the Foliage group. We're leaving density per polygon because the land cover attribute, prim%, is percent coverage. Turn to the Ecotype page and check Dissolve Enabled. Create a dissolve color texture. In the Texture Editor Elements section, load Complete Texture. Load the Pine Burn Ground Overlay texture from the component gallery. Go to the Groups page and add a foliage group. It doesn't matter what we call it because we'll replace it shortly. Load Foliage Group from the component gallery. Load the Burned Conifer Foliage Group. Density of the primary Overstory foliage group will be controlled by the prim% attribute. For that, create a thematic map to map the vector attribute to the group density. Rename the thematic map P42016 Group Density. We're mapping database objects whose primary attribute is 42016, so select the P42016 search query in the Dynamic Link drop-down list. Go to the Data page. Select the primary percent attribute, prim%, in the Channel 1 drop-down list as the mapped attribute. Close the Thematic Map and Ecotype editors. Back on the Ecosystem Editor Material and Foliage page, create a Material Ground Overlay diffuse color texture. Load Complete Texture. Load the Pine Burn Group Overlay texture from the component gallery. Go to the Ecosystem Editor Rules page and reduce the maximum slope to 35 degrees. Activate one of the land cover objects at the top of the list. Go to the Layer page, choose the land cover layer, and select the layer. Uncheck the render box. We don't need to render the vectors anymore. Save the project and render a Madison River preview. The P42016 ecosystem has the primary land cover as its overstory. Now it's time to add the understory ecotypes. Go to the lower Seen at a Glance pane and expand the search query category. Open the P42016 query. Select items now. As it turns out, all the primary 42016 vectors have the same secondary land cover, 42004. According to the lcname.txt file, that's lodgepole pine. The data doesn't tell us, but we know from fieldwork that the lodgepole pine are about 10 years old. Bring the Ecosystem Editor forward and go to the Material and Foliage page. We'll copy a texture, so edit the Overstory ecotype. go to the Ecotype page and copy the Dissolve Color texture. Close the editor. In the Ecosystem Editor, create an Understory ecotype. Go to the General page of the Ecotype Editor. Make absolute height in the Foliage group and absolute density in the Foliage group too. Turn to the Ecotype page. Check Dissolve Enabled and paste the Dissolve Color texture. Select Dissolve Color Texture as the copy target in the Copy Dissolve Color Texture window. Go to the Groups page and add a foliage group. Give it a temporary name. Load Foliage Group from the Component Gallery. Load the Lodgepole Pine Juvenile Foliage Group. Drop down to Group Density and create Thematic Map. This thematic map is for the S42004 Foliage Group Density, so name it S42004 Group Density. Make a dynamic link to a new search query. Name it S42004. Go to the Selected Filter page. This query will find database objects whose secondary attribute field is equal to 42004. Close the search query. Turn to the Thematic Map Editor data page. Select sec% as the Channel 1 mapped attribute. It's important to make provisions for the no data possibility. If this thematic map does not find any data meeting its criteria, we want to make sure it returns a 0 value and renders no foliage objects. Check the Use No Data value of 0. Close the editor. The thematic map we just created will search the database for secondary 42004 objects and map their secondary land cover percent to understory foliage group density. Open another Madison River camera in the upper right view. Save the project and render a preview. There's not much difference between the two renders. Let's look closer and see if we can figure out why. Open the Madison River zoom camera in the upper left view and render a preview. We have burned conifer packed in so close that we can't see the lodgepole pine understory. The problem here is twofold. First, the imported shapefile used a percent to define the amount of land cover in a polygon entity. While this may be the easiest value to obtain from an aerial photo, it is not a density. 100% coverage for a mature conifer forest is a different stems per area density than a grassland. Second, we use the percent attributes to define ecotype density in VNS. Go back to the Ecotype Editor General page. We left the density per polygon because that's the data we had. In VNS, density per polygon is density per rendered polygon after fractal depth subdivision. The Madison River zoom view was rendered at a maximum fractal depth of 3. At that fractal depth, the nearest DEM grid cells are subdivided into 128 polygons. On 10-meter terrain, that means an area of less than a square meter per rendered polygon. For an overstory with 80% coverage, that equates to a single 10 to 15 meter high burned conifer per square meter. We're going to determine a full coverage stems per unit area for each land cover type. The primary and secondary percentages will then be used to modify that value. The Understory Ecotype Editor is open, so let's start there. Change the density to per unit area on the General page. Leave the area units at hectare. Go to the Groups page. These lodgepole pine are Christmas tree size and grow fairly dense at this stage of forest fire recovery. A hectare is 100 ares, and an are is 100 square meters. That means 10,000 square meters per hectare. The group density plants a young lodgepole pine every 2 square meters with a density of 5,000 stems per area. We're defining the 100% density value at the foliage group level, so we can no longer use a thematic map here. Remove thematic link to the S42004 group density. Go to the Objects page. Each foliage object has a density field that is a percentage of the group density. Here's where we'll use the thematic map. We already have the S42004 group density, so link thematic map. The P42016 foliage window will pop up with a list of the project's thematic maps. Select the Understory S42004 group density thematic map and add item. The Understory Ecotype now uses the 42004 secondary percent attribute, sec%, to render a percent of the full coverage stems per area. Close the editor. Go to the Ecosystem Editor Material and Foliage page and edit the Overstory Ecotype. Turn to the Ecotype Editor General page and change the density to per unit area. Go to the Groups page. With the group density in stems per area, the 300 value now makes sense. This is the full coverage density. We've defined the 100% group density value, so remove thematic link to the P42016 group density. The Objects page is where we'll now use the thematic map to map primary land cover percentage. The first foliage object is active. Go down to Density and link thematic map. Select the Overstory P42016 group density thematic map in the P42016 foliage window. Select the second foliage object and repeat the process. Density link thematic map and select P42016 group density in the P42016 foliage window. Select the last foliage object. Density link thematic map and select P42016 group density. The Overstory Ecotype now uses the 42016 primary land cover percent to render a percent of the full coverage stems per unit area. Close the editor. Save the project and render a Madison River zoom preview. Render the upper right Madison River preview. The P42016 ecosystem uses two thematic maps, one to map overstory foliage density and one to map understory foliage density. Open the status log and let's see where that puts us with effects memory. The thematic map memory has increased 155 megabytes to 380 megabytes. Close the log. This works great when we have only one secondary land cover. But what happens when the same ecosystem has vectors with different secondary land covers? We're about to find out with the P42004 ecosystem. Go to the Vector task mode. Open the P42004 search query to the General page. Select Items Now in the search query. There are 6 vectors with the 42004 primary attribute. Land cover 3, 4, 10, 17, 20, and 22. Land cover 3 and 20 have a secondary attribute of 42001. Land cover 4 has a secondary attribute of 82002. Land cover 10 is 0, and land cover 17 and 22 are 42016. Go to the land cover task mode and open the P42004 Ecosystem Editor. Turn to the Rules page and change the maximum slope to 35 degrees. Go to the Material and Foliage page and create an Overstory ecotype. On the Ecotype Editor General page, make absolute height in the foliage group, absolute density in the foliage group, and density per unit area. Go to the Ecotype page and check Dissolve Enabled. Create a dissolve color texture. In the Texture Editor, load Complete Texture from the Component Gallery. Load the Pine Burn Ground Overlay texture. Close the Texture Editor. Go to the Groups page. Add a new foliage group and give it a temporary name. Load Foliage Group from the Component Gallery. This is the P42004 Overstory, which means the foliage group will be 42004 or Lodgepole Pine. Load the Lodgepole Pine Juvenile foliage group. Go to the Objects page. We'll control density with the thematic map, so create one. Go to the Thematic Map Editor General page. This is the primary 42004 density. Name it P42004 Foliage Density. Go to the Dynamic Link drop-down list and select the P42004 search query, which will find all primary 42004 objects. Turn to the Data page. This is the Overstory ecotype, so map primary percentage prim percy as the mapped attribute. If the thematic map does not find any data meeting its criteria, it should return a 0 value and render no foliage objects. Check the Use No Data value of 0. This thematic map will search the database for primary 42004 objects and map their primary land cover percentage to the Overstory foliage object density. Save the project. Open the status log and clear its contents. Open the Madison Lookout camera in the upper left view and render a preview. This camera zooms in on the foreground ridge in the Madison River view. We've left the ecosystem ground overlay red to make it easy to pick out the new ecosystem overstory. Thematic map memory is now almost 450 megabytes. We still have several more thematic maps to add, so this will be a good time to economize. Go to the Thematic Map Editor General page. Increase the resolution to 30 meters. Close the editor. Let's see if this has any obvious negative impact on the Madison Lookout render. Open another Madison Lookout camera in the upper right view. Save the project and render a preview. Thematic map memory has dropped to only 50 megabytes, and the render's no worse for it. Close the log. Let's replace the red ground overlay with a texture. Bring the Ecosystem Editor forward to the Material and Foliage page. Go to the Diffuse Color and Create Texture. Load complete texture in the texture editor. Once again, we're going to load the pine burn ground overlay texture. Close the texture editor. Save the project and render the left Madison Lookout preview. We'll need it shortly, so copy the diffuse color texture. Create an understory ecotype. Go to the General page of the Ecotype editor. Make absolute height in the foliage group, absolute density in the foliage group, and density per unit area. Turn to the Ecotype page and check Dissolve Enabled. Paste Dissolve Color Texture. Choose Dissolve Color as the copy target in the Copy Diffuse Color Texture window and apply. Go to the Groups page. We have 3 different secondary land covers associated with primary 42004 database objects: 42001, 82002, and 42016. That means 3 foliage groups. Add a foliage group and give it a temporary name. Load foliage group from the component gallery. 42001 is spruce fir. Load the spruce fir foliage group. Add another foliage group with a dummy name. 82002 is subalpine meadow. Load foliage group from the component gallery. Load the subalpine meadow. Add a third foliage group. 42016 is our old friend burned conifer. Don't worry about the name. Load foliage group. Load burned conifer from the component gallery. Now let's tell VNS where to render the foliage groups. Select the spruce fir group and go to the Objects page. We want all objects in this group to render only when the secondary land cover is 42001. Create a density thematic map. Name it S42001 Foliage Density. Create a new search query for the dynamic link. Go to the Selected Filter page. This query will find database objects whose secondary attribute field is equal to 42001. Close the query. Go to the Thematic Map Editor Data page. Select sec% as the Channel 1 mapped attribute. If the thematic map does not find any data meeting its criteria, it should return a 0 value and render no foliage objects. Check the Use No Data value of 0. Close the editor. Select the next foliage object in the list. Link Thematic Map to Density. Choose the S42001 Foliage Density in the P42004 Foliage window. Repeat the process and link the remaining foliage object densities to the S42001 Foliage Density Thematic Map. Go to the Groups page. We don't have any search query controls on the other 2 foliage groups yet. They'll render if we don't stop them, so disable them. Open the Fountain Flat Drive camera in the upper left view. Save the project and render a preview. As you may have guessed from the Overstory lodgepole pine and understory spruce fir combination, this is not a fire regrowth area. This lodgepole pine overstory ecotype is a mature forest. That means we need another Overstory foliage group for adult lodgepole pine and a way to render it appropriately. Close the Understory Ecotype editor. Edit the Overstory Ecotype. Go to the Groups page. Add another foliage group. Use a dummy name and load foliage group. Load Lodgepole Pine Adult from the component gallery. Select the first foliage group and go to the Objects page. Drop down to Density Thematic Operations and edit P42004 Foliage Density. Go to the Thematic Map Editor General page. Change the name to P42004 plus S42016 Foliage Density. Edit the P42004 search query. The current search query just looks for primary 42004 database objects. We need to narrow that search to P42004 objects with secondary burned conifer. Go to the Vector Task Mode. Clone the P42004 search query. Turn to the General page and rename it P42004 plus S42016. Add another filter that subtracts objects. Flip to the Selected Filter page. This filter will subtract database objects whose secondary attribute field is not equal to 42016. Return to the General page. Select Items now. Land cover 17 and 22 will be selected in the database editor. Clone the P42004 plus S42016 search query. Rename it P42004 minus S42016. Select the Subtract filter and go to the Selected Filter page. Deselect Not so the filter subtracts those secondary objects equal to 42016. Save the project. Go back to the Land Cover Task Mode. Go to the Ecotype Editor Groups page for the P42004 Overstory. We've taken care of creating the new search queries. Now we just have to link to thematic maps that use them. The lodgepole pine juvenile foliage needs to render when the secondary land cover is burned conifer 42016. Go to the Objects page. Drop down to Density Thematic Operations and edit the thematic map. Change the dynamic link to the P42004 plus S42016 search query. Turn to the Data page. Confirm that the thematic map will return a no data value of 0 if it does not find any data meeting its criteria. While we're here, expand Thematic Maps in the Scene at a Glance. Clone P42004 plus S42016 Foliage Density. Go to its cloned Thematic Map Editor General page and rename it P42004 minus S42016 Foliage Density. Link to the P42004 minus S42016 search query. Close the editor. Go to the Ecotype Editor Groups page. Select the Lodgepole Pine Adult group. Turn to the Objects page. Go to Density Thematic Operations and link Thematic Map. Select the P42004 minus S42016 Foliage Density we just created. Select the Lodgepole 5.iff24 foliage object. Density link thematic map to P42004 minus S42016 foliage density. Save the project and render a fountain flat drive preview. You may have forgotten about it, but we're not done with the P42004 ecosystem. We still have 2 disabled understory ecotypes to Thematic Map. Compared to what we've just done, they'll be easy to set up. Edit the understory ecotype. Go to the Ecotype Editor Groups page. Select the Subalpine Meadow Foliage group and enable it. Go to the Objects page. Create a density thematic map. Subalpine Meadow is the 82002 land cover. Name the thematic map S82002 foliage density. Add a new search query from the Dynamic Link drop-down list. Go to the search query General page. Name the search query S82002. Go to the selected filter page. Search the secondary attribute field for values equal to 82002. Return to the General page. Select items now in the search query. Open the Plan Default camera in the upper right view and switch to real-time mode. Land Cover 4 is the small vector area at the bottom center of the view. Close the search query. Go to the Thematic Map Editor Data page. Select sec% as the Channel 1 mapped attribute. Check the Use No Data value of 0. Close the editor. Select the next foliage object in the Ecotype editor. Link the density to the S82002 foliage density thematic map. Repeat the process and link the remaining foliage objects to the thematic map. Save the project. Open the River Bend camera in the upper left view and render a preview. This vector-bounded P42004 ecosystem has 10% subalpine meadow as a secondary land cover. There's not much, but we can see a few flowers among the trees. Back in the Understory Ecotype editor, we have one foliage group left to set up. Go to the Groups page. Select the Burned Conifer Foliage group and enable it. Go to the Objects page. Create a density thematic map. Burned Conifer is the 42016 land cover. Go to the Thematic Map General page and name it S42016 foliage density. Add a new search query from the Dynamic Link drop-down list. Name the search query S42016. Go to the selected filter page. Search the secondary attribute field for values equal to 42016. Return to the General page. Select items now in the search query. 4 land cover objects will be selected in the database. Close the search query. Go to the Thematic Map Editor Data page. Select sec% as the Channel 1 mapped attribute. Check the Use No Data value of 0. Close the editor. Go to the Ecotype Editor Objects page. Select the second foliage object. Link the density to the S42016 foliage density thematic map. Repeat the process and link the last foliage object to the thematic map. Save the project. Open the Madison Lookout camera in the upper left view and render a preview. The P42016 ecosystem on the left has burned conifer as primary cover and young lodgepole pine as secondary cover. Lodgepole pine dominates the P42004 ecosystem on the right as primary cover, with burned conifer as the secondary cover. If you're not sure you can see the difference, go to the Groups page and disable the burned conifer group. Burned conifer is the understory in this P42004 ecosystem vector. Open the Madison Lookout camera in the upper right view and render a preview. Enable the burned conifer group. We still have the P62002, P74001, and P82002 ecosystems left. Fortunately, they are already built, complete with thematic maps and search queries. Open the P62002 Ecosystem Editor. Open Component Gallery. Land cover 62002 is grass-dominated wetland. Load P62002 from the Component Gallery. The loaded component links to objects and components that already exist in the project. To use the existing project objects, choose Link to each window that pops up. Open the default camera in the upper right view and switch to real-time mode. In the database, land cover 2 and 19 are primary 62002 vectors. Open the wetland camera in the upper left view and switch back to real-time mode. It looks west across the land cover 19 vector area. Save the project and render a wetland preview. Mature lodgepole pine is the secondary land cover here. Open the P74001 Ecosystem Editor. Open Component Gallery. Land cover 74001 is basin exposed rock soil. Load P74001 from the Component Gallery. Once again, the loaded component links to components that already exist in the project. To use the existing objects, choose Link to each window that pops up. In the database, the primary 74001 ecosystem is represented by land cover 11. As the primary land cover implies, this ecosystem is a little different. Go to the Ecosystem Editor, Material and Foliage page if you're not already there. This ecosystem land cover is primarily basin-exposed rock soil. In VNS speak, that's ground effect. Everything that isn't foliage should render ground effect, so the material ground overlay is set to be 100% transparent. Edit the Overstory ecotype. Go to the Ecotype Editor Ecotype page. Edit the Dissolve Color texture. The Dissolve Color texture is a modified version of the ground effect hydrothermal deposits material. A brown-green fractal noise texture has been added to simulate patches of grass. Close the editor. Close the Ecotype Editor. Edit the Understory ecotype. There's only one primary 74001 vector object in the database, which gives us only one secondary land cover, 42016 burned conifer. Turn to the Objects page. Foliage object density is controlled by the S42016 foliage density thematic map we created earlier in the tutorial. Close the editor. Open the upper geyser basin camera in the upper left view and switch back to real-time mode. It looks northwest across the land cover 11 vector area. Save the project and render a preview. Open the P82002 Ecosystem Editor. Open Component Gallery. Land cover 82002 is subalpine meadow. Load P82002 from the component gallery. The loaded component links to foliage objects and search queries that already exist in the project. To use the existing objects, choose Link to each window that pops up. In the database, the primary 74001 ecosystem is represented by vectors land cover 18 and 8. Open the Sentinel Meadows camera in the upper left view and switch back to real-time mode. It looks west across the land cover 8 vector area. Save the project and render a preview. Basin exposed rock soil is the secondary land cover here. Open the Sagebrush camera in the upper left view and switch back to real-time mode. It looks east across the land cover 18 vector area. Save the project and render a preview. Mountain Big Sagebrush is the secondary land cover here.